Hello. Welcome to another recording for one of the classes for this statistics class that I'm teaching. Once again, the way this is going to go is that I'll be discussing a topic in statistics. I'll be pausing at several moments and asking you to complete an activity, which will be available on Google Classroom, and complete those activities for credit. Okay, let's get into it. So, the topic for today is going to be data sources, and then we'll also talk briefly about data cleaning. Data sources and data cleaning. And we're going to be discussing this topic in a way that's kind of, I'm going to say, big picture. We're going to be moving away from the particulars of different types of data sources and different types of data cleaning or different issues in data cleaning. And we're going to be talking more about the idea of data sources and data cleaning. This class is going to be sort of theoretical in its focus. Theoretical in the sense of like big picture, overarching ideas and issues, more so than in the sense of the formal theory. Later, we will have a class that focuses more on practical issues related to collecting data and organizing that data. But this one's going to be kind of big picture. This topic is related to the idea of types of data, which you may recall we talked about way towards the beginning of the semester. In that class, we talked about how you can have categorical data, you can have quantitative data, etc. There's different types of data. And when we discussed that class, we talked about data as if it fits neatly into certain boxes. There's, in general, sort of a tendency in statistics classes to treat data, to treat numbers, to treat the materials on which we do statistical operations as if they already existed. You know, in a statistics class, you're often kind of given statistics, numbers, data to work with. But in real life, you have to go get those things. You have to go collect that data. And it turns out that this process is not particularly straightforward, and it has implications for the interpretation of whatever it is that you end up finding with that collection process. This class is going to focus on the kind of issues you encounter during the collection of data. The next class that we do is going to focus on the interpretation of data once it's been collected and analyzed. How do you then interpret it? Of course, these two topics are very closely related to each other. How you collect data affects how you're going to be able to interpret it, and there are major issues and limitations surrounding the entire thing. The other thing that I want to mention before we jump into the topic itself is that this class is going to be much more about raising questions and issues rather than solving them or giving explanations of what you should do. And this is because the issue we're about to discuss, the issue of how to collect data, different sources of data, limitations of those practices, it's a topic that has no clean solution. It's an ongoing debate and probably always will be an ongoing debate. The question is, what's the best way to collect data on a given subject? And how do I know what that is? This is the question that we're faced with at the first step of any kind of study, any kind of research, any kind of data analysis. Okay. we'll go ahead and just start off with the first activity right now. We'll kind of put down our initial ideas. Go ahead and write a little bit about, pause the video and write a little bit about how do researchers collect data? Anything you already know about? What are some of the issues with collecting data? So go ahead and write your thoughts about this. Whatever you already know about, you can feel free to look a few things up as well. Okay, hopefully that went well for you. Again, just putting down some initial ideas. Now, if you chose to look up these questions here, it's likely that a lot of the results that you saw had to do with kind of a list of methods. Discipline specific, they may mention observations, interviews, surveys, tests, and so on like this. Again, this class is going to be less about going through that list and more about thinking about this question in the broad sense. Okay, what do I mean by that? Well, one of the major concerns in any kind of data collection and analysis is the question of the issue, the question that we don't just want to get meaningless numbers. Like, yes, I can go out there and I can collect information. I can turn that information to numbers. I can run a statistical analysis on it. But that only matters if the numbers that I collected actually mean something. For example, I could, if I wanted to, go into my bathroom and count the number of tiles that are in my bathroom. Then I could go into my kitchen and count the number of tiles in my kitchen. And I could do a statistical comparison on the number of tiles in my bathroom and the number of tiles in my kitchen. But why would I do this? What would it tell me? What would be the point of a study like that? Statistical methods, as we've been learning them to this point, have largely been unconcerned with those kinds of questions. When you're just dealing with raw numbers, it doesn't matter where those numbers came from. We do the same operations on them regardless. But when we really want to understand statistics and how it works in the real world, we need to think about this question. We want numbers that actually represent something that matters to us. And the question is, how do you get those kinds of numbers? How do you get that kind of information? The technical term for this consideration is validity. And you'll hear about this in various research methods type classes. Validity is a very broad term, and it's been defined in many different ways. People have identified different types of validity, but all of them have to do with, does the information we have actually represent what we care about? All of them have to do with this basic consideration. Okay. There are kind of 2 points in a data collection process where we have to be concerned with this issue of validity. The first one is when we're collecting data in the first place. And the issue here is that the questions you ask or the methods that you use to collect data affect the results you get. It's hard to know what you're leaving out. Again, examples of these principles are coming right up. Okay, and then the second problem, the second point where issues with validity can occur, where we're not sure if the numbers that we're looking at, the information we're looking at, really matches up with the thing that we care about. The second problem is that once you have data, once you collect it, once you have those numbers, that information, you have to organize it or comb through it. You have to make decisions both when you are first collecting that data, and you have to make more decisions when you are going over the data you have and trying to piece it together and begin the process of interpreting it. All of this precedes what we have traditionally been talking about as statistical analyses, where we do mathematical operations on that data. These problems come before all of that. We've done no math so far. We're still having issues. We're still running into important decisions in our statistical analysis. Okay, what I'm going to do is I'm going to walk through a scenario. And this scenario is going to try to illustrate some of the issues that I've just talked about up here. Again, I'm only going to be giving one example in class today, but know that these principles apply all over. They're general issues in research, data collection, data analysis. So we'll think about these things in one context, know that these same issues apply in many other contexts as well. And they express themselves a little bit different in every context, but they're always present. Okay. So let's get into that scenario. And again, I'll be posing a lot of questions and issues to you and not giving a lot of answers as we walk through the scenario because, again, there aren't a lot of clear answers. Okay. So let me first of all give you the premise of a study. Let's start with that. Okay. So let's say that I am an education researcher. Pick education because it's something that I know a little bit more about, so I'm going to use that as an example. And I want to compare two teaching methods. First of all, there's going to be a more traditional method where students are taught with a lecture, homework, classwork, written assignments, multiple choice tests, things that are relatively standard and straightforward. And then I'm going to also be testing a new, more experimental, interactive method of teaching where rather than a teacher leading the class, students are going to co-lead the class. You may have experienced classes that were like this. You may have experienced classes where one or two classes were like this, but I'm going to go the extra mile. I'm going to have the whole class just be students co-leading. The teacher is only there to facilitate. Take that example and move it in towards the extreme. Let's say that the subject of these classes are going to be about is economics and finance. Just to pick one. Okay. And so I managed to get, say, a school to agree to help me with my experiment, with my comparison. And And they agree to have a situation where they're going to have, let's say, these 1, 2, 3 classes at this school. Here's the people in the classes. All these classes have students in them. And these classes are going to be the ones that are taught normally, same way that they've been teaching them in the past. And then we're going to get to see 1, 2, 3 classes that are taught in the new style that we're trying out as an experiment. Okay. These are going to be taught with the interactive method. Okay. So what I've just described to you is a pretty a classic kind of experimental design where we're going to have a control group, traditional methods, and an interactive group, which is the experimental group. Okay. And the question that I want to answer, the sort of key question, is which method is better? Ultimately, I want to make some kind of recommendation that we switch to this method or that we keep using the original method. What I really care about is which one of these methods is the better method for teaching students. Okay. And the question is, the next question that I'm faced with as I'm trying to design this study is, how will I measure this? I want to know which method is better, the traditional method or the new method that we're trying out. The question that I'm faced with is, how should I measure which one of these approaches is better? It's not so easy to answer this question. First of all, the first thing I need to think about is, well, what makes a method better than another one? What makes a teaching method better than another one? Is it learning? Am I looking for which group of students learns more? Which type of teaching method teaches more? How about experience? Am I looking at, well, which one of these methods creates a better subjective experience for students? Maybe I care about which one of these methods creates a better experience for teachers. I mean, they're part of the process too. And then if I go over here to learning, I can also think a little bit more about this. I can say, well, what kind of learning do I care about really? Learning about economic facts? Well, how about financial skills? There's a difference between being able to say things about economics and being able to actually manage your own money. Which one of those things do I care about more? Which one of those do I think constitutes real learning? How about what they call soft skills, where in which class are students learning more skills like how to speak well, how to interact with other people, how to promote teamwork, the so-called soft skills. Any one of these things could be something that I care about in terms of evaluating which method is better than the other one. How about something like cost? This matters too. This could be cost in terms of money. It could be cost in terms of time invested into making these methods work, materials, etc. I also might care about something like, and we're running out of space here, see, we've got so many considerations. Who does this work for? It may turn out to be the case that certain methods of teaching work better for some students and other methods of teaching work better for other students. Maybe there's a difference between male and female students in terms of whether they do better in the traditional course or the interactive course. Maybe there's a difference between low and high performing students, where students who average a C in their other classes do this way, students who average an A in their other classes do another way. So these are the considerations that I have to make. What exactly is it about these classes that are going to make them better or worse? And you might notice that I'm already having to face some somewhat subjective decisions where I have to say, well, I think that learning is what really matters, or I think that the student's experience is what really matters, or hey, you really got to keep an eye on those costs. Which one of those factors is the one that really does matter to which method is better? It's not so clear. I might have to make a judgment call at this step. And this is only the first problem that I have, because even once I choose which one of these things I'm going to focus on, I still need to also answer the question of how will I measure these things. So let's say I pick student learning. As the thing that I'm saying is really the best measurement of how good the class is, which method is better. Does it make some sense? Okay. Well, the question is, how am I going to measure student learning in a way that I can compare these two classes? Well, maybe my first instinct is, well, I'll just look at student grades. And I'll compare them, the grades between the traditional classes to the interactive classes, and I'll say whose students are getting the higher grades. However, there's a problem here. One of the problems is that, for example, different teachers grade differently. You yourself may have experienced classes where you have a teacher who's pretty easy on grading, get an easy A, and another class where the teacher's very strict about grading. Another problem is that, and this has been found in a lot of educational studies, students will get good grades, then forget everything. Like, 2 weeks later. You yourself may have experienced this, where you got a good grade on an exam, and then like 2 weeks later, asking any question about that material, and boy, could you have a hard time answering it. So maybe I don't trust grades, the grades given by the teachers of these classes, as a good measurement of learning, because I don't feel like I can compare the grades that students are getting between these classes, because I think that the teachers are going to do the grading differently and the assessment differently. And maybe I feel like grades aren't a good representation of learning, which is what I really care about, because it's too easy for people to do well but then forget immediately. So maybe I want to make my own test that I'm going to give independently of the teachers that are operating these classes. And I'm going to give the same test to all of the students. Maybe I'll set it up so that I give that test a little bit after the course is completed. Well, what should that test be? Should it be an exam? Should it be multiple choice? Should it be short response? Should it be an essay? Should it be written at all? Should it be an oral exam? Should it be some kind of project-based or applied exam? If I decide to do a project-based or applied exam, how do I evaluate the results of that project? How do I say this is a good project, this is a bad project? I'm going to have to make a rubric of some description, some kind of grading scheme. But then I have to decide what's on that rubric. Do I care more about the clarity of the presentation, the structure of the thoughts and the way they're put together, the delivery? What am I choosing to prioritize? What do I think really demonstrates students' learning? What do I think learning is? These are questions I need to answer before I even go and get a single number. Of course, there are other options as well. When I'm trying to sit up and do a research study, I'm faced with all of these options, and I need to try to make a decision about which one I think really represents students' learning in a way that matters, in a way that I care about. And I need to think about which one of these things is something that I can measure. I might think that a project-based learning approach or a project-based assessment approach really demonstrates learning in the best way, but I need to be concerned about how I'm then going to fairly measure those results. Same thing with short response answers. How do I say, well, that's a good short response answer and that one's not? I have a lot of options and it's not clear which one is the best. I have to weigh advantages and disadvantages. And importantly, I'm already starting to influence the results of my test. And I haven't even started collecting any data yet. For example, let's say that the interactive class is better at teaching skills. It's better at teaching how to manage money, how to invest, how to set up accounts, how to look at markets and things like this. It's better teaching that. Let's say that the more traditional method is better at teaching knowledge. Technical terms for economic trends, concepts, institutions, knowledge of the institutions that regulate finance. The kind of things that you could test with a written exam. Well, I might need to test these things in different ways. A multiple choice exam might be better at telling me about how much knowledge students have about a subject, but it might not tell me a lot about the skills that they have. A project-based exam might be better at helping students display those skills, but might not tell me as much about how much knowledge they have because the project will have some focus and I don't know how much they know outside of that focus that the project is dedicated towards. Maybe there's ways around these issues. Maybe I can give both kinds of exams. I can try to combine different approaches. But whatever I do, I will get a certain picture of those students' learning. And that picture will be different depending on which type of testing method that I choose. Okay. Again, a lot of questions here, not a lot of answers, but that's kind of the point. Let me go ahead and give you the next activity now. I want you to come up with another way we could measure student learning about this subject. So we've given the options of an exam, a multiple choice exam, short response, an essay, an oral exam, project-based or applied exam. What's another way that I could try to assess students' learning about this subject? Then I want you to pick a method or combination of methods that would be best. Explain why you think that. Okay. So the activity is to, first of all, come up with another way we could measure student learning that wasn't mentioned before. Then to pick a method or a combination of methods that you think would be the best at establishing how much students have learned in these two courses, or two methods. And then give a little explanation of why you think that. There's no wrong answer. I just want you to go through the process of trying to think that way. So go ahead and pause the video, work on that, and come back when you're done. Okay. Let's head back in here. Now, hopefully you're getting a sense here for the kind of issues that a researcher runs into when they're trying to think about how to collect data, just at the very broad planning level. Let me show you this with another example, which again, I'll go through this example a little bit quicker, but to show you that these problems exist no matter what method we end up trying to adopt. Let's imagine that we roll the clock back a little bit and I decide that, what's important to which method is better? Students' experiences in the class. Okay, maybe one of these methods helps students learn more, but if they learn more but they have a very negative experience as they're doing that learning, they might not be inclined to continue to care about and learn about this subject after the class ends. So based on that argument, based on that rationale, I say I think student experience is what really matters. So now I need to come up with methods for trying to assess the student experience. Well, how am I going to do that? Once again, I have a couple of options. There's a couple of important things here. One thing I need to consider is, what are the relevant questions I also need to consider, how do I know people are telling me what they really think? Sometimes it's not so easy. People, of course, can lie and they can misrepresent their own beliefs. Of course, I once again have to think about, how do I get data I can measure and analyze as well. I have a lot of options. I could do a survey. Maybe I'll have an agree/disagree or true/false kind of setup. I can do interviews with students as well. I could also do observations of students in the classroom and see, do they look like they're enjoying themselves? Maybe I feel like the teachers matter as well. Maybe I can, for example, ask teachers for their impressions of student experiences. Which one of these sources of data is going to be the best at helping me to answer these questions, deal with these issues? Well, it's not so clear. On the one hand, surveys might be a good way for me to get data that I can measure, because I can control what kind of answers people can give. However, people don't always take surveys seriously, and a lot of the times when people take surveys, they feel like they want to give an answer, but that answer isn't one of the options. Surveys can limit people's ability to explain their answers, take away some nuance. Interviews can give more nuance, but they take a lot of time. People might feel pressured to answer in certain ways. They're harder to analyze and compare the results of. Observations of students in the classroom itself can be effective. However, people might change their behavior when they know that they're being watched. This is a huge issue with this form of data collection. It's also hard to watch everybody. Maybe it's I sitting in the classroom trying to observe students' behavior. Are they enjoying the class? Are they not enjoying the class? Well, I run into issues where I can't watch everybody. Maybe it's easier for me to notice the students that are having a bad time. Maybe it's easier for me to notice students that are having a good time. Maybe I can ask teachers for their impressions. This can help me with the fact that I can't observe everything, but teachers have their own biases. They might not know what's going on inside of their students' heads either. Once again, I have to think about what I want to prioritize. Am I interested in students' enjoyment of the class? Or how about their engagement, which might be a little different from enjoyment? Or maybe their interest while they're in the class. Maybe I want to ask students questions about their intent to keep learning about the subject, about economics in this case. Which one of these focuses would give me the best idea of whether the students are having a good experience or not of the class? It's not so clear. I have to make choices. I have a lot of choices. It's not immediately obvious which one is the best one. I also have to think about being able to compare the results of whatever I do between these two methods. But it might be the case that some questions that I want to ask to one of the teaching methods won't make sense in the context of the other teaching method. What do I mean? Well, for example, I might want to ask people in the interactive section what they thought of what their experience was of the various group activities that they did. But if I ask that same question to people from the traditional method, they might be sitting there like, what group activities? We didn't do group activities. So I want to ask them that question, but it's hard to compare it to the other group because I can't ask them the same question. They didn't do the thing that this group did. That's kind of the point of the whole experiment. So should I ask the traditional group about what they thought about the lectures or assignments that they did? Is that an equivalent question? Can I directly compare those answers to the questions that I asked to the interactive group about the group work that they did? It's not so clear. It's not obvious. And again, once again, just like with the different ways of measuring learning, whatever options I choose to try to measure these things, whatever I prioritize, I'm going to be stuck with the problem where I don't know what I would have found if I had done something different. Whatever I commit to, I'm going to be leaving out whatever I would have found if I had done the other options. Maybe I think I can try to combine options and I can give a bunch of different assessments, an exam, a project, an oral exam, an essay, and I think, well, I can also give a survey, and I can do interviews, and I can ask the teachers for their impressions, and I can do observations. I'll do it all. But then I run into issues of I only got so much time. People, it's the students in this case, they got other stuff to do. They're only going to be willing to do my assessments, answer my questions for so long before they're like, come on, man, I can't do this anymore. So we have to prioritize, we have to choose certain options, and it's not clear which ones we should choose, and the ones that we choose will affect the kind of results that we get. Very tricky. Okay. Let's go to the next activity, third one. And this time we'll think about, how we would want to get information about the students' experience of the classes. Go ahead and write the questions you think would be most important to ask in this situation, in this scenario. Why would these questions be the most important? So again, our goal is to understand the students' experiences of the class, to see if they had a better experience in the traditional classes or the interactive classes. The issue we have is that we need to figure out what questions we think would be the most important ones to ask in order to get at that information. Okay, go ahead and pause the video. Take some time to try to answer this prompt. Okay, hopefully you had some ideas there. All right, so again, the point of the presentation to date has been to raise these issues where, when we're designing the study, we have to make choices about how we're going to collect data, and depending on what choices we make, we're going to get different kinds of data. It's going to influence our results, and therefore it's going to influence our ability to interpret those results. It's going to sort of paint our picture. Now we'll move into kind of that second point that I mentioned at the beginning of the presentation here, which has to do with, okay, now we have some data, and before we do any statistics on that data, before we do any math on that data, we still need to make decisions, we still need to make interpretations, we still need to make some tough calls. Things are not always obvious. Let me go ahead and open up a new point here. Now, let's say that we do this study. Again, we look at these classrooms. We have the different teaching methods. Let's just imagine that I had decided that the way that I wanted to do the study was that I wanted to prioritize looking at student learning. And the way I decided to test that was with a very long exam. Let's say that exam has 300 questions. as multiple choice. The reason that I went for this method of assessment of student learning was I wanted to ask students as many questions as possible to give them the most opportunity to display their knowledge. I decided to go with a multiple choice format because I knew it would give me data that I could easily analyze, quantitative data, and compare between the two classes. Again, I decided to give the same exam to both of the classes. Now, this has downsides. Maybe one of these methods of teaching is not good at preparing people for exams. It's better at preparing people to do projects. But I've accepted that you can't do everything all at once. We're just going to use this method of assessment. Okay. Let's say that again, I designed this exam with 300 questions, multiple choice, and I only expect students to get about a 100 to 150. Where if you paid attention in the class, you did well in the class, I expect you to get about a 100 on this exam. I've intentionally put a lot of questions on, a lot of varied questions on to see if I can get at the full extent of your learning. Okay, and let's say that I'm looking at one of the classes that was tested. Let's say this is one of the interactive classes. Let's say it's the second one. Could have been any of them. Let's just say it's the second one. And I'm looking at the data that I collected. I'm looking at the results of these exams and how many questions students got right on those exams. Okay. And I have my axis down here. I have the scores that students have gotten on the exam, where here you got 0 right, and here you got 50 right, here you got 100, and I'll just have my distribution here. So far everything looks normal. Okay. I have this distribution, and I'm just looking at the scores that students got on this distribution here. And I'm seeing that, just like I expected, a lot of students are getting scores in the 100 to 150 zone. This is kind of what I thought we would see, where most of the scores are piling up in the 100 to 150 zone. A couple of students, maybe they didn't pay as much attention, they're getting scores that are a little lower. And a couple of students did particularly well, they're getting scores that are a little higher. This is kind of where most of the scores are lining up, just like I thought. And I'm looking through this data, and suddenly I see that one student seems to have gotten a particularly high score. And I keep looking through the data. Again, most people are getting scores in the middle here. They're scoring 150, they're scoring a little higher, they're scoring a little lower. And then I come across a student who seems to have gotten an extremely low score. And I keep looking. Most people are getting the scores I thought they would get. And I come up and I see another student has gotten a very high score. And I keep looking and I see, once again, a student has gotten a very low score. Let's say that this student here got something like a 270. This student here got 270. And this student here got a 280. much higher scores than I thought would even be possible to get on this huge exam. Let's say the students down here both got a 10. Well, this is the situation I'm in. In general, these scores, these very low scores and very high scores, are called outliers. You may have heard of them before. These would be low outliers and these would be high outliers. And I mentioned them earlier in the class, and when I mentioned them earlier in the class, I mentioned that outliers are very tricky to respond to. The question that I have as I'm looking at this information that I just looked at, is what does this mean? What do these scores actually represent? What do these scores represent down here? Well, the first thought might be that there could have been some kind of entry error, some kind of recording error. Or for example, these two students who both seem to have gotten a 10, maybe their scores were really a 100. But when the person was entering their score into the tracking sheet, they accidentally wrote a 10 in. If those scores were actually 100, that would put them back here with the main group. Maybe these scores were also entered incorrectly. Maybe that 7 is supposed to be a 10, where they got a 210 rather than 270. That would be convenient for me because it would easily explain away the problem. But maybe that's not the case. Maybe these students here just did really well in the exam. They studied ultra super hard in the economics class. They looked at extra materials. They really got into the subject. They just scored really high on the exam. What do you want from them? Maybe these students down here just did really poorly on the exam. They didn't pay a lot of attention in the class. They were out most of the time. They just did poorly on the exam. Maybe the students who got high scores cheated somehow. Maybe they got some kind of advanced copy of the exam. Maybe the students who got low scores down here, well, maybe they just didn't try on the exam. They said, I'm not passing this class anyway, or something like that. They showed up, they didn't really put any effort in. Answered 2 questions and left. It's hard to say. Maybe one of these students down here they just had some kind of nervousness during that exam, some kind of panic attack, and they exited the building before they finished. Maybe one of these students up here, their dad is an economist. They talk about these things all the time. I don't know. All I'm looking at is a bunch of numbers. And I need to try to explain what these numbers mean, and I don't know what these numbers mean. Let's say that these students really did do very well in the exam because they really did know all the information on it. Well, is that because the class did a really good job teaching them? Or is that because of personal factors that meant they were always going to do really well in this exam? They just have an interest in the subject, family knows about it. Any economics class they took, they were going to do well in it. Doesn't matter how they were taught. Maybe the students down here are just dealing with a lot of personal issues. They got a lot going on. They were going to do poorly on any exam we gave them, no matter how we taught them. Just looking here at these numbers on this page, it's really hard to tell what's going on. how to explain what happened in these unusual cases. Unfortunately, it's like too late for us. We might want to go get clarification on these situations, but that might be hard to do because the class is already over, the students have moved on. And the question that I'm faced with as a researcher looking at data that's distributed like this is, what do I do about it? How do I explain this? Many researchers, when faced with a situation like this, where there's a couple of high numbers, a couple of low numbers that are just hard to explain how this happened, everyone else seems to be following this trend, a couple people seem like they didn't somehow, many researchers would just drop these points. Just delete them. They'd say, okay, I'm just going to assume that this was some kind of entry error, that this doesn't represent any kind of real trend. I'll just get rid of them and I'll present my analysis as if these points were the only ones that I got. I'll pretend like these never existed. But is that decision really a legitimate decision? Again, it's what a lot of people would do. But doing that might discount these students up here. Maybe they really did do well in the course, and maybe they really did well in the course because it was interactive and that inspired them, that propelled them. Maybe the interactive teaching approach, one of its advantages is that it encourages some students to really go the extra mile and get all the way into a subject. Not all the students, not a lot of the students, but some of them. Or maybe not. Once again, we have a situation where there are unclear interpretive choices, and they're going to affect how we see the results of this study, and it's not 100% obvious what the right thing to do is. And we haven't even started doing math yet. We're just looking at these numbers. Okay. That brings us to the last activity for today. What I want you to do is imagine that you're in this situation right here, where you're kind of wrapping up a study, you are looking at the data you have, and you see that you have a couple of low points, a couple of high points that are way far away from the rest of the data. What would you do in this situation as an analyst? How would you interpret, follow up on, and report these results? And why would you do that? Okay, go ahead, pause the video and take some time to answer these questions. Okay, hopefully that went well for you. Okay, that kind of brings us towards the end of the presentation here. Again, just raising these issues, not providing a lot of answers because there really aren't a lot of clear answers to these issues. And everything we've just discussed here, all these considerations, the difficulties of these considerations, it's not over yet because in the next class we're going to talk about the issues that still arise after we do all of this. It turns out we're still not done. I also want to mention before we wrap up here that most professional researchers, most scholars, people who devote their time towards thinking about how to learn things and how to know things, most of them agree that these kinds of decisions are tough. They're judgment calls, but they're solvable. You can ultimately arrive at better methods, better data, and better conclusions. But some people don't accept that these are solvable, addressable problems, and they reject research results in general on those grounds. People in the sort of critical theory tradition. One way or another, it's an ongoing debate. It's a never-ending question of, I have something that I want to know about. How do I collect data on it in a way that will really tell me about the thing that I want to know? It's not always so clear. Okay, that concludes the video, and see you around.